So evaluated by the binomial theorem, a plus b to the power n is equal to n choose 0 an plus n1 an minus 1 plus n2 an minus 2. And so here there must be a b2. So you keep going until you get nn. Actually, before you get to nn, you get to n r, an minus r, b r. You go until you're at nn, bn. Now, if you decide to solve for n to 0, you will get n factorial 0 factorial over n minus 0, which is n factorial. This will give us 1. If we decide to solve n choose 1, we'll get n factorial 1 factorial n minus 1 factorial. And we saw what happened when we were solving question 2, that we can reduce n and then it will take away the n factorial down, so this remains to be n. If we choose to solve n choose 2, then we'll get n factorial 2 factorial n minus 2 factorial, and this is n minus 1 n minus 2 factorial over 2 factorial n minus 2 factorial. But this part and this part can cancel, and then we get this over 2 factorial. We can keep going. If we do 3, we'll get n factorial 3 factorial n minus 3 factorial, which becomes n minus 1 n minus 2 n minus 3 factorial over 3 factorial n minus 3 factorial. And this part and that part gets cancelled, so we remain with n minus 1 n minus 2 over 3 factorial. This means that we can as well write a plus b to the power n as, instead of saying n to 0, we just say 1, so let's use a to the power n. Saying n choose 1, we just say n and then a n minus 1 b. Instead of saying n choose 2, we'll say n minus 1 over 2 factorial a n minus 2 b2. Saying n choose 3, we just say n minus 1 n minus 2 over 3 factorial a n minus 3 b3, and it will keep going. So that if where there is a, we have 1, and where there is b, we have x, and we substitute on the right, then it will just be 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 n minus 2 over 3 factorial x3, and you keep going like that. So that if where there is x here, we have bx n, then we have 1 plus n bx plus n minus 1 over 2 factorial bx squared plus n minus 1 n minus 2 over 3 factorial bx to the power 3. We can now go to question 4 and answer A. What does A say? Find the first 3 terms in the expansion of each of the following. A, 2 minus x to the power 5. This means n is 5, a is 2, b is negative x. So you can follow the simplified expansion, this one, so that we do not waste time. So we have 2 to the power 5 plus 5 as our n, a 5 minus 1 multiplied by b plus 5 minus 1 over 2, 2 to the power 5 minus 2 multiplied by negative x squared, and you keep going. This is 32 plus 5, 2 to the power 4 negative x plus 5, 4, 2 to the power 3 over 2 x squared, and you keep going like that. So that we get 32 plus 5 by 16 negative x plus 5 by 2 by 8 x squared by 2, because this 2 reduces that 4 to 2. And this becomes 32. We can now put minus because of the negative x. So we have minus 80x plus 80x squared. So you get that because you're interested only in the first 3 terms. B 1 minus 4y multiplied by 1 minus 5y to the power 8. Now 1 minus 4y, we don't do an expansion. The power is 1. But 1 minus 5y to the power 8, we have n is 8, a is 1, b is negative 5y. So we use this expression, which is easy. But because there's an attachment, so we're going to use the last expression. So use this expression where we don't do anything to the 1. So we just say 1 plus 8, which is n, multiplied by negative 5, plus 8, which is n, 8 minus 1, which is 7, negative 5y squared over 2. We could keep going, so end here, which becomes 1 minus 4y, 1 minus 40y, 2 here 1, 2 there 4, so we get 28. So we get 28 here, we get 28 by, so you can stop scribbling so that we concentrate. So you get 28 by 25 y squared. So that you can then expand 1 by everything inside. You get that 28, 25 y squared, and then minus, you now multiply 4y by the other parts, so you get 4y plus 160 y squared. You end there because even if you multiply this by this, it's going to give us to the power 3, which is the 4th term, when you just want to have the first 3 terms. So this becomes 44y plus 28 by 25 plus 160 y squared. So you can finish up the inside part. Of multiplying that. So for C and D, you just follow the same pattern. So you can go to question 5. Question 5, given 1 plus 2y to the power 7 is equal to 1 plus ay plus by squared plus cy3. Find a, b, c. In other words, you are being told to expand this up to the term y3 and then get the coefficients. So we know that the expansion of this will be 1 plus 7 multiplied by 2y plus 7 minus 1, 6 divided by 2 multiplied 2y squared plus 7 minus 1, 6, 7 minus 2, 5, divide by 3 factorial, which is 6, and then 2y to the power 3. This is 1 plus 14y plus this, here we have 3, so we get 21 by 4 y squared plus 6 and 6 there cancels, so we have 35 by 8 y3. So that we get 1 plus 14y plus plus 44 y squared plus, you now multiply 35 by 8. So you get 2.
So
Yes.
is it supposed to be 84 squared?
Okay, yeah. Because that's 2 1 by 4. Okay, thank you. So 84y squared. And then 35 by 8. To what?
280.
To 8. Okay. So now we want to find A. So A is going to be 14, the coefficient of y. B is going to be 84, coefficient of y squared. And C is going to be 280, the coefficient of y3. It means that we've answered the question fully. Then we go to question 6. Write the term indicated in the expansion of each of the following. For A, you want the fourth term, given the expansion 1 plus 2y to the power 7. We're just from doing that question. And if we counted the terms 1, 2, 3, 4, our fourth term would be 280 y3. So we are saying from the expansion, the fourth term is 280 y3. In case we did not expand, or in case the powers were too big and the term asked was too far, how do we get to the answer easily? In this expansion, we had this part here. That part there is the general term. So asked to find the fourth term, we'll write that term as that. So we want a fourth term, so we should make this equal to 4. So r plus 1 is equal to 4, so that r is 3. So we have t 4 here, and our n from the question is 7, which is the power. We have found r to be 3, and then now we have a as 1. I don't even put the power because they won't change anything. Then b is 2y to the power r, and r is 3. So we have 7 factorial, 3 factorial, 4 factorial multiplied by 8 y3. That is 7 by 6 by 5 by 4 factorial over 3 by 2 by 4 factorial, 8 y3. So this part and this part cancels. So we get 3 and 2 takes away 6. So we have again 7 by 3. This is 3. This is 5. 7 by 5, giving us 35. Then by 8, then y3. This is what we got as 280 y3. So we still get the same term using different methods. So in case I've forgotten the general formula, the general term formula, I can do the expansion and count the terms and pick the term that I'm asked to do. Find. For B, we want a fifth term dealing with x squared minus 1 over x to the power 8. Now, one thing I know is if I have 1 over x, I can write it as x to the power negative 1. It means the same. So, what we'll do now is we'll say, okay, then t 5. Remember that 5 there, it was supposed to be r plus 1. So now r plus 1 is equal to 5, implying that r itself will be 4. And so we have n to be 8, r 4, a x squared, n minus r, that will be 8 minus 4, which is 4, and then negative x, negative 1 to the power r, and r is 4. So we have 8, 4, x 8, negative 1, 4, x negative 4. If I have 8 and negative 4 there and the base is x for both, then I know I will just remain with this x to the power 4, because 8 minus 4 will give me 4. Negative 1 to the power 4 is just positive 1. And positive 1 by x4 is just x4. Then you solve for 8 factorial now. 4 factorial, 4 factorial, x4, which becomes 8 by 7 by 6 by 5 by 4 factorial x4 over 4 factorial, then the other one will expand it. So that this 4 factorial takes away the 4 factorial there. This 4 and this 2 go with 8. This 3 will reduce 6 to 2. So we have 2 by 5, 10. 10 by 7, 70. So we get 70 x to the power 4 as the term, the fifth term of the expansion.
So
Yes.
when there is -1, now if we had -2, we're supposed to multiply 70.
Yes, we would have multiplied firstly 2 to
As
the
the
power
as
4. Okay, so firstly 2 to the power 4, you get 16. That's 16 you multiply by 70.
Okay, thank you, sir.
All right. Do we have any other question? This is question time because we are ending. So I have uploaded some topics that we haven't done now that we are doing maybe next week or after next week, like trigonometry. Then I'm also about to upload logarithms and exponentials. So if you did a notification on your subscription and you subscribe there, then you'll be notified as I post, so that you can be ahead. And then as we come solving the tutorial sheets, there will be nothing challenging. So have a good day.